positive original message from the tool, and there was place for other annotation. I'll touch on it later. So to describe some of the problems, format was not expressive enough. It did not support, for example, multiple traces. It turned out to be underspecified, and it took us 3 weeks to convert tool reports to the format that we wanted. There were some little details. Some weaknesses may not map to CWE-IDs well, and we had a lot of weakness names that we had to somehow reconcile. And severity classification is very subjective. Tools use different things to rate their weaknesses. So what the tool makers did, they converted their tool reports to our SATE output format. They described the environment in which they ran the tool, so which operating system, some other detail. Some of them also provided analysis of their reports, and some of them provided critique of our analysis. That was very helpful, but unfortunately, we didn't give them enough time to do that, so some did not, just due to the time constraints. And want to note that we did not provide them any context for running the test cases, so they could assume the worst case of environment. Now, about the tool reports, they mostly handled the code well, which is not trivial for the size of programs. There was some very interesting analysis. There was a total of almost 48,000 warnings, so that was huge, and it caused us a lot of problems because we didn't have enough resources to analyze it. It just by simple calculation, it takes, you can come up with man years to analyze everything thoroughly. And there were about 100 different CWE-IDs in the reports, and 291 different weakness names. Of course, some are very similar, so in some cases it was easy to combine, to understand that they are really referred to the same weakness type. So now, this is the division of warning by test case. And one thing to note is that this very big part in the bottom, it's for OpenNMS. So this skews, this biases the results of any analysis that we do because of so many warnings there. Now this is a division of warnings by severity as assigned by the tool. So severity 1 and 2 are the subsets that we decided to focus on simply due to the lack of resources. And that, of course, causes a lot of problems because this is fairly, well, even in the lower severity issues, there are many different cases, many interesting cases to consider. So partly to make a better presentation and partly to simplify our analysis, we also divided the weaknesses into 3 broad categories. Based on security relevance, this is strictly based on the weakness name and CWE-ID. So let's say in the high category, we put all XSS warnings, SQL injection, other input validation problems, race conditions, buffer errors, authentication, authorization, and so forth. So these are types of weaknesses. Within those, there may be some warnings which don't really qualify as high severity issues. This is just based on the weakness names. So we had also medium and low categories. And even in the low categories, there are some interesting cases. It's just that in looking at the weakness name, we thought that we can put it there. So this is a division of warnings by weakness category for the Java test cases and for the C test cases. And of course, in case of the C test cases, we subtracted the flow finder reports. The reason is that we had certain difficulties in qualifying the weaknesses from this tool in which category we should put them, so we decided to subtract them. And I will use this weakness category, will refer to these weakness categories later. So this is the warnings for the high security relevance category for the Java track. This has a fairly large, XSS is a big part, is about half of all the weakness reports in that category. And there are SQL injection, command injection, other types of issues reported by the tools. This is, by the way, these numbers are just the number of raw warnings produced by the tools, so some of them may refer to the same weakness. I will talk a little bit about it later. These are the warnings for the C track, and there is a prevalence of buffer errors. This is maybe again due to the way we classified them. So buffer errors, buffer overflows, and related stuff. And again, this is without the reports from Flow Finder. Some general ideas about, because we had a human, a company that did a manual analysis here, we can have some ideas about the comparison here. This is again just qualitative. So tools are fairly good for XSS, types of injections, and memory problems. They are okay for some classes of authentication errors and information disclosure. And you need human help for the types of problems where you have authorization problems, logic flaws, the complicated, some complicated cases of other weaknesses. But of course, tools can quickly report hundreds of weaknesses for some classes, so that's of course an advantage of automation. Now, analysis of tool reports. This is how we felt. So I need to tell you about what kind of, about our criteria and also what kind of problems we have. So first, you have to classify whether it's false or true positive, and it turned out not a trivial problem at all. Then severity, in our opinion, sometimes we would assign a severity to a weakness that is different from what the tool assigned. And I give an example where input comes from configuration file during installation. So we would downgrade the severity to 5 because it's not really a problem, but tool doesn't know about this because it doesn't have the context. And we also try to associate the warnings that refer to the same weakness. And due to lack of resources, we focused only on severity 1 and 2 issues and missed a lot of important issues. So about the false or true positive, we assume that tool doesn't know about context or environment, but we expected that the tool understands the code. So if you, for example, if you report a particular problem within a function, let's say, but the function is called everywhere correctly, so it's not really a problem.